In this circuit, we have a current controlled voltage source, which its voltage value depends on current Ix passing through the resistor R2. This dependent voltage source is in series with a fixed 10-volt source. And the goal of this problem is to find VL, the voltage across the resistor RL. To solve this problem, we can use the Thevenin equivalent circuit. The Thevenin equivalent of a linear electrical circuit is an independent voltage source called VTH in series with a resistance RTH. The Thevenin equivalent voltage VTH is the open circuit voltage at the output terminals of the original circuit. In this example, the open circuit voltage is the voltage across the resistor R2. Now to find the VTH, first we can write a Kirchhoff voltage law KVL to calculate the current Ix. As you can see here, this 10-volt source is in series with dependent source, and this is why they are added up in the KVL equation. Now we simplify this expression and substitute the values in. The next step is to calculate Thevenin equivalent resistance RTH. This resistance can be determined by dividing VTH by the short circuit current at the load or output terminal. By the way, if you like what you are watching, please hit the like button and also subscribe to the channel if you haven't done yet. Now back to the video. By short-circuiting the load terminals, we can determine the ISC, and simplified circuit will look like as the following. As you can see here, the Ix becomes 0 because all the current in the loop will go through the short circuit path, and respectively, dependent voltage source also becomes 0 and gets replaced with a closed connection. So we can write respectively RTH will be Now, since we found the Thevenin equivalent of the original circuit, we can find the voltage across the load resistor. So let's calculate the load current IL. And by Ohm's law, we can obtain the value of the VL. Thanks for following along. If this video helped you, don't forget to like and subscribe to the channel.